Well, here we are again, students. It's Miss Wilson coming to you from your past and talking to you about systems of equations, an objective that you guys mastered last year, hopefully. So we're going to do it really fast, just spend 3 days here, and talk about the 3 different ways of solving these. The first being graphing, my least favorite, substitution, and elimination, which is also called combination sometimes. And that's actually my favorite one. But I do need to teach you graphing, or at least review graphing with you. Now remember, if you have two equations, if you have two variables, you have to have two equations to solve it. And one way of doing that is graphing it and looking at their point of intersection. So right here they have an intersection of coordinate 3, 2. And so to make sure that I'm correct, I'm going to plug it into both points. There's no need to get these wrong, especially when you can check them. Now the type we're going to work with here is consistent and independent. Consistent means there's a solution, and independent means and there's only one solution. So here's 3 examples of problems, and I have my grid. Let me move it. And typically if they give me the problems like this, which is standard version, ax by, then I tend to want to do the x and y intercepts because that's real easy to do in my head. We have a problem here, though. This one, the y-intercept is 0, and let me tell you what's going to happen. If I erase the 5x, then y is 0, and then when I erase the y, the x is 0. So I can't do that one with x and y intercepts. So I am going to have to change that first one to function form, y equals 5x. So my first point, it's the same thing as 5x plus 0. My y-intercept is 0, and then I count off 5 up, 1 over, and I graph that very imperfectly because I can't draw a straight line, and I don't have a ruler on the screen. For the other one, I'm just going to find the x and y intercepts. If I take the y out, 5x is 10, which means x is 2. So I go over here in the x-axis and I put a 2. So that leaves, if x is 0, the y is 10. So I go to where the y is 10 and I connect these two. Now, I'm betting you're already looking at what a crude way of doing this is, because I think my solution is 1, 5. But I don't really know. It was lucky enough to cross in the crosshairs or intersect in the crosshairs, if you know what I mean. So imagine if it was 1 and 1/5 or 6/5. That would be almost impossible to tell. So I checked 1, 5 in both equations, not just one but both, and I see it's correct. Now this one, I'm going to do the x and y intercept. If negative x is 3, then x is negative 3. So I plot one point there. There's my x-intercept. And then I'm looking at that first equation on number 2. The y-intercept is 3/2, so I connect these two. On the other one, 2x equals 4 means that x is 2. I'm looking for the x-intercept, and there it is. I just plotted it. And the y is 4. And I connect, and I'm hoping that that coordinate where they intersect is 1, 2. To know if I've got this right or not, I just go to the original equation, and I'm going to try it in both problems. Negative 1 plus 4 is indeed 3. I plug the 1 in for the x and the 2 in for the y, and the second one works as well. Feel really good. Know I'm going to get this problem right. Feeling a good grade coming on. This one, the x-intercept is 5, so I go down to the 5 and I plot the point. And if negative y is equal to 5, that means y is equal to negative 5. So I'm just doing my x, y intercepts on each equation because it's faster than converting it to function form and then counting it off. So on 3x plus y equals 3, if I take the y out, 3x equals 3, therefore x equals 1, and I plot the point, and y is of course 3. I connect, praying that I'm doing a straight line because everything hinges on that, and I've got 2, negative 3. Wanting to know if that's correct, I go up and I plug it into the original equations. So 2 minus negative 3 is 5. That one's correct. And 3 times 2 is 6, plus negative 3 is indeed 3. Again, you can see why this is not my favorite. It's labor intensive and it's not all that accurate. So I wanted to do this one. I thought this was a hard problem. And I thought, okay, let me see if the kids can do this. I'm going to change 1.6x and 3.2y by multiplying every single thing there by 10. And then I'm going to solve negative 16x is equal to negative 240. I'm looking for my x-intercept. So therefore x must be 15. And before I graph it, I'm going to go ahead and find out what x and y is because I'm not sure. It looks so big that I'm thinking that I need to be careful about how I number it. So it would be premature to actually start drawing the grid until I know what my x and y intercepts are. So I know that x is 15 and the y is 15 halves, or as a lot of people like to say, Amori, you're one of them, you love the decimals, 7.5. So for the other one, I'm going to multiply everything by 10 again. 26x plus 26y is 260. Oh, this is not hard. So 26x is 260 for the x-intercept. X is 10, and y is going to be the same thing. So I know how I need to number this thing now. I really don't need quadrant 2, 3, or 4. So I'm numbering this, and you're sitting patiently watching. This is a little dull for you, I'm sure. Sorry. I would be going slower if y'all had not already had this, but I know that you did. So I will not insult you by dumbing this down. We're just going to fly through this. All right, so if my y-intercept is 10 and my x-intercept is 10 for that second equation, I connect those. And on the second one, my x-intercept is 15. Oh, well, I didn't number it far enough, but I'm going to remedy that right now. And there's my 15. Change the color so you can see it more clearly. And then 15 halves are 7.5 for the other point. I sure do hope these cross at the crosshair so I can tell what it is. Okay, I'm gonna guesstimate that to be 7. I don't know. What do you think that is? You think it's 7.4? So I would have to plug in 7 and 4. I'm pretty sure I did this and it didn't work. I'm using my calculator right now. You can't see that, but yeah. That's not right. It's not right. So what do? See, I'm not a fan of the graphing, but you do have to know how it's done, what a consistent system looks like. So, and that if it's, in standard form, you can find the x and y intercepts. This is, to me, the least accurate. So this concludes, oh, look how good my circle is. This concludes my lesson on graphing. You guys have a good evening.